right, so on, let's see, Wednesday, I guess, we started distance on the coordinate plane. You were supposed to watch the video. And the video got us all the way to example 7, which is actually on page 14. And so we want to look through starting at number 7. So with number 7, it says, what is the distance between these 2 points? -4, 6, and 2, 14. Give your answer in simplest radical form, important information, so I'm going to underline it, and rounded to the nearest tenth if necessary. So basically, it wants us to do both. It wants us to put it in simplest radical form, which is the exact, okay, and then it wants us to put it in to the nearest tenth, which is our approximate answer. So, yes, you can put this on the coordinate grid like we did in number 5, but we want to use the actual distance formula. So I'm going to go ahead and write that out again. The distance formula is distance is equal to the square root, and oh my goodness, what just happened? And we want a big, long square root, okay? And we're going to say the square root of x2 minus x1 squared, that whole quantity squared, plus y2 minus y1, all that quantity squared, okay? So that's our distance formula, and we're going to use that to solve and find the distance between these 2 points. So first thing I want to do is I want to label my x's and my y's, okay? And then I want to be more specific. So let's look at our first coordinate. I'm going to say this is my x coordinate, this is my y. This is my x coordinate, this is my y. And then I want to be more specific and say, well, this is my first coordinate, so both my x and my y's are 1s. This right here is my second coordinate, so I'm going to have not a 1 there, a 2 on each of those, okay? Then I can just plug these into my equation. So I'm going to say distance is equal to, and we're going to say x2, which we know based on what we filled out, that is a 2. Okay, and then we have minus our x1, so minus a -4. That quantity squared. We have a plus sign in between, and then we have y2, which we know is 14, minus our y1, which we have as 6. And that whole quantity needs to be squared. Okay, so we're going to say this distance is equal to, we have 2 minus a -4. Well, whenever we have 2 negatives like this, it becomes positive. So I'm going to make that into a positive, and I get 2 plus 4 is 6 squared. Plus, and then we have 14 minus 6, which is going to give us 8 squared. And then we can say, well, that's equal to the square root of 36 plus 64, which is equal to the square root of 100. And if we take the square root of 100, we get 10. So my exact answer is 10. And since I don't really have a decimal, it says to the nearest tenth, so I'm going to put 10 point, and I want to have that tenths place, so we're just going to put 10.0. Okay? And both of these are going to be just units as our units. Okay, you can also abbreviate units with a U. That works too. Okay, let's move on to number 8. So this one is where it can get a little tricky, just remembering what you're supposed to do with these. So we want to know the length, and basically we're just given a number line. So whenever we find the length, we're looking from D to J. And what we're going to do is we are going to subtract the 2. Okay? So we are going to subtract the 2 and basically take the absolute value. So if it's negative, it's always going to be positive because, again, length cannot be negative. Okay, important. I would write that down and make sure you remember that. Okay, so what I'm going to do is I'm going to take my biggest number and I'm going to subtract my smallest number. Now, it looks like negative 75 is my biggest number, but negative 20 is actually bigger than negative 75 because it's closer to 0. Okay, so we have negative 20 minus a negative 75. Like I said, you're subtracting the 2. So those negatives become a positive, and we have negative 20 plus 75. And that gives us 55. So that means that DJ is 55 units. Okay, then it's also asking for JA. Okay, again, we're taking our bigger number and we're subtracting our smaller number. So our bigger number is 60 minus our negative 20. Those become positive and we get that JA is 80 units. Okay, then it's asking for DA. Okay, and DA is that green distance, it's all the way across. Well, we've already found DJ, which was 55, and we already found JA, which was 80. So if we want to find that entire distance, we can just add those together, and that gives us 135 units. It says, what do you notice about the answers from A to C? What it's basically asking you to tell them is that the length cannot be negative. So every answer is a positive answer. So every answer is positive. Okay? Again, very, very important whenever you're talking about distance. So then it says, well, if DF has a length of 15 units, okay, what are the possible locations of F? I'm going to erase what I have going up here. And it's saying one of your points is at D. Okay, so we're going to be here at D. And then it's saying, well, your length of DF is 15 units. So we can either be 15 units this way, or we can be 15 units that direction. So it's saying, what are those possible locations of F? So basically what I'm going to do is I'm going to add 15 to negative 75, and I'm going to subtract it from negative 75. And it should give me 2 locations. So if I'm at negative 75, and I add 15, I end up at negative 60. So around here is going to be negative 60. So that's one location that F could be at. The other location that F could be at is if I'm at negative 75 and I subtract 15. That means I'm going to be over here, and that's going to be around negative 90. Okay. All right, moving on here. I lost some of my star. There we go. Okay, so for part F, it says AB is congruent to AJ. Where is B located? So basically it's saying AB is going to be an equal distance. J is going to be an equal distance from A as it is from J. Oh my goodness gracious, I did not say that right. A is going to be an equal distance to J as it is to B. There we go. That sounds better. So we know that AJ, right here, we know that's 80 units. So basically what it's saying is, where's B going to be located? So if that's 80 units, we have to go 80 units this direction. Okay, so if we go 80 units the opposite direction, we have to add 80 to that 60, which gives us 140. So that means we're going to be located way out here at B, and that's going to be around 140. Okay, that way if you look, from J to A is 80 units, and that means then from A to B would be 80 units as well. Okay, this is going to be the first of our proofs that we do. So please pay attention to this very well, because this is where it gets a little bit more confusing. Okay, so it says, suppose that points A, B, and C are collinear with point B between points A and C. Okay, so we're going to draw this. Collinear means that you're on the same line. So that means that we have A, B, and C all on the same line. Okay, and it says point B is between A and C, which I have, which I already have labeled. Then it says if AC is equal to 21, so if this entire length, oh, what just happened? It just disappeared. If that entire length is 21, then it says BC is 15 minus X, and AB is 4 plus 2X. We want to solve for X and find the measurements of BC and AB. And it tells us to sketch a picture, which we've already done. So, whenever we're doing problems like this, we always want to start out with the first statement being that AB plus my other portion, so plus BC is equal to the entire distance across that line. Okay, so it's equal to AC. This is what we call, the reasoning for this is what we call segment addition postulate. Okay, that is called the segment addition. We're adding segments together to get our full segment. Our next thing we have to do is substitute some stuff in. So we know that AB, they told us in the directions, where'd it go? That AB is equal to 4 plus 2x. So I'm going to sub in 4 plus 2x for AB. They also said, so I'm going to put up my plus sign, they also told me that BC is equal to 15 minus x. which is equal to AC, and they told me AC was equal to 21. Okay, so what I just did was I subbed in what I knew all of these line segments were equal to. So I'm going to say that I can do that. The reasoning I can do that is by substitution. Okay. Then for part 3, we should know then that our x's can combine. So I have 2x minus 1x, which is going to give me just x, or 1x. And then I also have 4 plus 15, which gives me 19. And that is all equal to 21. And what we just did is combining like terms. So combine like terms. This should be something you did a lot of last year. Okay, then I'm just gonna keep solving this equation like I normally would. So I am gonna show some work here in between lines. I'm gonna subtract 19 on both sides, which leaves me with my answer for 4, x equals, that 21 minus 19 is 2, okay? So in order to get to line 4, I had to subtract that 19 on both sides. So what that's called is the subtraction. And then I'm gonna write it out one time, but you really don't have to. What I do is I say subtraction property of equality. That's the big long version. There we go. How I abbreviate that is I say SPOE. So subtraction property of equality. It just, I think that saves a lot of time instead of writing that all out. Okay, so my answer would finally be x equals 2. So I solved for x. Now I need to find the measurement of BC and AB. So if I want to find those measurements, I'm just kind of going to do that off to the side up here. I have BC is equal to, what I want to do is I want to plug in my 2 for x. So I'm going to say 15 minus 2, which gives me 13. I also need to find AB because it tells me to in the directions. So I'm going to say 4 plus 2 times 2. Okay, so 2 times 2 is 4. Add another 4 to that and we get 8. Okay, and we are done with problem number 9. Okay, 10. It says draw a diagram to represent the situation. So I'm going to draw a diagram down here by like number 11. And then it says solve for x and justify your reasoning. And you are given if P is between L and A. So I'm going to draw my line. And it says if P is in between L and A, PL is equal to x plus 4. PA is equal to 2x minus 1. And LA, so this entire segment, is equal to 5x minus 3. Then x is equal to what? We're going to figure that out. And it says to sketch a picture. Okay, so this is going to be very, very similar to number 9. So we're going to start by saying, well, we have LP plus PA. And we know that entire thing is going to be equal to the entire line segment, LA. Okay, and we can say that by the segment. I'm going to abbreviate. So segment addition postulate. Like I said, I'm just abbreviating. It's the same thing as number 9. That should be a 1 though. Okay, then we're going to follow the same step we did for the second part of number 9. We're going to substitute. So we're going to say, well, LP, we were told, was x plus 4. We were also told that PA is 2x minus 1. And then we were told that LA is 5x minus 3. Okay, so we were told all of this, and so we substituted all of that into our equation. So substitution. Okay. Then again, we kind of follow the same steps as number 9. We're going to combine our like terms. We have x plus 2x gives me 3x. And then I have 4 minus 1 is a positive 3. And that's equal to, we can't combine anything on this side of my equal sign. So we're just going to say that's equal to 5x minus 3. Okay, and we could go from 2 to 3 by combining like terms. I also abbreviate combining like terms to CLT. Or you can, like I said, or you can definitely write out combine like terms. It is completely up to you. Okay. My next step is I just have to find a way to solve this like I normally would an equation. So what I'm going to do is I'm going to subtract this 3x over. If I do that, I'm left with 3 is equal to 2x minus 3. Okay, and I got to number 4 by the subtraction property of equality. Okay, then to get to my next step, I'm going to have to get my x's all on one side by themselves. So I'm going to add this 3 over to the other side, which leaves me with 6 is equal to 2x. And since I added this time, it's just the addition property of equality. Okay. I still don't have x completely solved for. If I want to solve this equation, I have to divide everything by 2, which leaves me with 3 is equal to x. And that is by dividing, so the division property of equality. And I have my final answer as x equals 3. Now the only other thing it says for number 11 from question 10, the length of LA is what? So if I want to know what LA is, I have to plug in what I know x is. So I'm going to say 5 times 3 is 15 minus 3 gives me 12. Okay. All right, and that is it for the distance formula. So that is it for page 14. If you have any questions, please make sure you are asking in class.